Hi, my name is Adolfo Garcia. I work at a new startup company called Carabiner Systems, and I'm part of some of the OpenSSF folks that are giving some talks at the conference. I am at OpenSSF. I am one of the technical leads of the OpenVEX project and also of the Protobomb project. And so we will hopefully show you a couple of tools that we have in the works that will facilitate some of the exercises during the workshop. I am also active on the Kubernetes community, where I work on the release engineering team, which handles all of the SBOM and supply chain security features of the Kubernetes release process.
Hey, everybody. I'm Mike, CTO at a startup in supply chain security called Kusari. I'm also a governing board member and a technical advisory council member of the OpenSSF, Open Source Security Foundation, for those who aren't super familiar. I'm also a maintainer of various open source projects, including GUAC, which we'll learn about a little later, as well as SLSA, which is a secure build framework. And I'm also a tech lead in TAG Security for the CNCF. So for those who aren't super familiar, TAG Security is just, cloud native, Kubernetes, stuff like that. It's where we all kind of come together to talk about, policy and a bunch of other things and how sort of to secure things in a cloud native way, as well as to approach how to secure cloud native, which is often at the forefront of stuff. And then at the top there is a QR code for a free book that recently got released about a week ago that myself and Brendan Lum from Google wrote. It's just pretty much all about supply chain security. Feel free to take that,
Yeah. And then I'm last in Dunbar-Hall. I'm also a governing board member of the OpenSSF and active a lot in ECMA International, which is TC54's overseas Cyclone DX. And then I see a lot of friendly folks from the CISA communities, so do a lot there. Also a maintainer on bomctl and SBOMit, which are two projects within OpenSSF working with SBOMs. We'll demo a little bit about bomctl in this presentation. Hobbies. I almost quit my tech job to go be a commercial brewer, do a lot of backpacking, and now I'm a proud T-ball parent, repping the Norfolk Tides T-ball team. We do have a Gitpod environment that we encourage you to follow along with. That is the URL at the bottom. So tinyurl.com/sbom-workshop. We'll also be showing that along the way, but if you want to follow along step by step, you can also do it there. So what are we kind of covering today? We're going to really kind of break it down into three sections. I'll say better SBOM generation. That's really the key part of this first part, is talking about how do we make better, higher, I'll say quality, more complete SBOMs. I know quality is a touchy subject when it comes to SBOMs. We'll be talking a little bit about sharing, and then how do you get SBOMs from one place to another, and then operations. Once you have it, what do you do with it? Again, so I think the last slide with this URL, it's not hard to remember. Definitely open up a laptop and follow along.
Yeah. Also, if there's any questions while we're kind of doing this, while one of us is talking, feel free to raise your hand if you're having a trouble installing something or running a particular command. One of us will stop by and help you. And then obviously, if multiple people all seem to be having an issue, we can kind of take a step back as well. But I think before getting into it, do we want to just, how many of you all, by raising your hands, have generated SBOMs before? All right, about half or a little more than half. How about have shared SBOMs or otherwise distributed SBOMs? Okay, a little bit few folks less. And then how many folks are consuming SBOMs and actually analyzing them and using them for? Okay, also about half. Okay, thanks. That helps.
So yeah, when we start out by saying better SBOM generation, what we're talking about is the majority of people who generate SBOMs, they pull out their favorite tool, A couple vendors in the room have their own, right? But ultimately, people will run it across the code base. They'll maybe decompose a binary and generate an SBOM, and they say, ship it. It's great. And they never actually look at the contents of it. I was telling a joke earlier, but it is a true story. I got a really terrible SBOM back on April 1st, where like someone literally had insert company name as the vendor, and they had the Acme Corporation software license for it as the company licensed product. And I thought it was an April Fool's joke. That is, I'd say, very common that people generate an SBOM and they ship it. They never actually look at the contents of it. And so a big part of what we talk about when we're saying better SBOM generation is like, let's fill in those missing fields that actually make these things practical beyond just a list of components. So these small changes really do lead to big improvements in the quality of your SBOM. And I really encourage folks to do more than just pull out Sift, Trivy, some other tool, and generate an SBOM and slap it on the project and send it out. For this portion, we're going to be following the SBOM producer lifecycle. This is something that came out of the SLSA Tiger teams. So as we started looking through making reference implementations on how to generate SBOMs, we said, okay, like we started like most people do. You generate an SBOM, you look at the contents of it, and you say, gee, it's missing all this information that we really want. So how do we begin to populate those additional fields that we're missing? The first step of that is augmentation. And we look at that as how do you add the top level metadata to the document and to your top level component that only you as the software producer really know, right? What is your copyright? What is the description of the product? Where do you find the documentation links? What's the license? All of these things typically cannot be gleaned by a SBOM generation tool. You as the producer need to declare what they are. Next up is enrichment. That's adding missing metadata to all the components that you have listed, right? And so we talk about NTI minimum elements, you talk about any other standard. You really want to see a lot of these missing fields populated. How do you go about doing that? Once you've created an SBOM, how do you verify it? By schema, overall completeness, but also through attestations and other mechanisms. Before you then go on and you sign it, right? You declare like, you signed it, I'm declaring that this is what the released SBOM is by whoever produced it. And then we're not going to cover it in this. It could be an entire separate presentation, but I'll say document linking, right? We talked about the dependencies within an SBOM between different components. Well, let's expand that. What does that look like for a higher level system where you may have multiple SBOMs that represent a system? They can't just be distinctly separate files. You have to somehow link them to represent the overall system. Another topic, another day. So we talk about generation, choose your favorite. In this case, the example is Trivy. Right, choose whatever you want. Standard options, I'd say favorite tool doesn't matter. Favorite standard doesn't matter. Favorite format doesn't matter. Choose an SBOM generation of any type. I think I'm preaching to the choir here, but your favorite tool will vary probably depending on what package manager you use. If you're doing C, C++, like I see runtime security back here looking at the phones. Hi. That's a great example of how to generate really high quality C, C++ SBOMs, right? A lot of these other tools don't do a good job of that, right? Choose the appropriate tool for what you're doing. So here we ran Trivy. This is for Keycloak. But you'll see like, hey, there's a whole bunch of stuff that, in my opinion, is missing that's pretty valuable, right? So stuff like author, the supplier, repository location, right? My company, we run a giant fast open source scanning system where we need to know where to find the original repositories for all of the open source components. We can do deeper analysis of them. Gee, it'd be great if I don't have to maintain a database of what that is. Tell me where you got your open source components that you passed along. Again, license, copyright, other things that from a legal perspective, you want to declare. I see a number of SBOMs where a company says, no assertion on the copyright. Come on, this is your product. Take credit for it, right? Those are important things for you to declare as part of your SBOM. So really, how do we go about beginning to add that stuff? that's where augmentation jumps in. So in our definition, augmentation is really focused on the top level metadata for the document and the component. There's a couple different ways that you could do this. Ultimately, you want to have it automated as part of your pipeline, right? Everything here should be reproducible. There's two ways that I've approached this problem. I'd love to hear if others have different ways. There's a tool that's an open source tool from Interlinks called SBOM that does a really good job of allowing you to augment this top level metadata, be it for SPDX or CycloneDX. The way I've historically done it is you write out some JSON and you use JQ and you smash it together. I'd love to hear other ways to approach this, but this is typically how I've done it. Again, how do you get this top level metadata into your SBOM that may not otherwise exist? So we're going to switch over to our little Git pod environment here. So again, I encourage you to follow along. You can try all this yourself. This is also all directly in a GitHub project here, if you just want to follow along with the steps. All right. So in this case, we're going to do something on, we're going to generate an SBOM for kubectl, kubectl. Allow me to do this. Is there a way to undo that? Oh, thank you. A whole bunch of Mac users trying to use the Windows computer. So we downloaded it, we generated an SBOM. The generated SBOM misses a whole bunch of stuff, right? It's got just a very basic top level metadata, top level component, and then going through the probably 4,000 plus components. So here's kind of the same command that we would run. We're going to go through and run SBOM twice. Once to edit the top level document data, metadata, and then again to update the top level component data. In this case, adding an author or supplier, what part of the life cycle, right? We often debate what type of SBOM something is. We're giving it a repository where you can find source code and then a license, along with a path or a URL for that. Let's go ahead and run this. And let's take a look at that diff. Let's see what it actually added as part of that. All right, so it did a couple things here. It generated a new serial number. You can debate whether or not that was necessary, but it's interesting that it did that. We've added that life cycle now, so we know what type of SBOM it is. It's added itself as an additional tool. That's great. It's such the SBOM. We now know what tools were used to generate this SBOM. And you can hear Mike rant about knowing that information later on in the presentation. Yeah. And then now it's added the author, right? So it's saying who generated this, our workshop here, along with all that supplier information. So it's saying, the URL for where to find Kubernetes, and then also the other, not only the document author, but who's added all these components, us, along with the license and external references to where you can find the repository. All right, so we've added some useful information here right out of the gate. Pretty simple, easy to add into your build pipeline. But it really begins to expand on what's available for the consumer of your SBOM to make it more useful, right? Myself, again, what are the two primary cases? We often talk about security, we're at VulnerabilityCon, right? But the other big part of it is licenses, is legal. So knowing copyright, knowing what licenses are actually applicable here are super important. So we'll switch back over to the slides. Switch it all back over again. All right. So just to reiterate, right, the SBOM approach that we just showed there, we've declared what we want to modify, in this case, the document. We've added a whole bunch of of additional metadata and basically generated a new BOM. And we kind of showed some of this already, right? We've added a new phase, who the author is, the supplier, repository location, and license information. The other way you can do this, right, is through what I've historically done, and it only really works well for CycloneDX. It's not really it's not a great approach for SPDX, but generate a static JSON file, check it in your repository, and just use JQ to smash the two together. And again, pretty simple, easy step you can add into any sort of build pipeline to add all this top-level augmented SBOM data. I personally prefer now the SBOM ASM approach, just because it works great for both CycloneDX and SPDX. And really helps, you know, at the end of the day, be consistent. If the formats change sometime down the road, you don't have to worry about trying to re-smash everything together. Excuse me here. All right, so enrichment. We talked about updating all the top-level metadata. Gee, like that's useful. Now let's talk about the individual components. Most build tools today are not throwing in all that extra license, documentation links, all that other stuff for each individual component. How do we go about doing that? A lot of that information is, you know, say mandatory under the NTIA minimum elements, but I've yet to see an SBOM generator that actually introduces it. I personally have, my company has, you know, contract requirements to meet the NTIA minimum elements. And I need to have my suppliers give me SBOMs that meet the minimum elements. How do we do this in a way that is cost effective for small mom and pop software producers? Well, Sneak has written Parlay. It does a shockingly good job at this. And it will reach out, in this case, to ecosystems, which is one of a couple different databases out there that tries to categorize all this information for open source components. And it will enrich that SBOM. It will go in and add documentation links, licenses, authors, all that kind of stuff. Granted, we don't really know what the quality of that is, but it will do a really good job from my experience along the way there. So here's just an example of a single component. On the left, you see kind of like what that component CycloneDX looked like to what it became. It added description, it added licenses, added a lot of external references to where the website, how it's distributed, documentation, and other interesting properties, like when was this project first released? What is the latest it's been updated? For me, as a consumer, this gives me a lot of additional information where I go do that deep analysis of an SBOM. I can go look at all these individual repositories and begin to do deeper scanning and whatnot. So let's do that. I'm also going to try to make it look nice at the same time. So we're going to run Parlay, tell it to use ecosystems. They have a couple other data sets. And then we'll tell it to enrich the SBOM, and then we'll make it pretty at the same time. All right. So let's diff that in comparison to the already augmented SBOM. So we're not going to look at the original generated SBOM. We augmented it. We're now going to compare it to the enriched one. So you can kind of see here a lot of that information. You know, this is choosing a random package on top, but it's gone through and added all those external references. And its release dates. This one may have already had supplier. Oh, it didn't. Okay. Next one down to, you know, like Semver, starts adding things like who the supplier is, the name, who the author is, licenses, additional resources along the way. So again, a lot of additional information that's been injected to into the SBOM with a pretty easy step. We went through, go for it.
noise that does actually help us, but makes it go from like 189 lines of text to like a billion.
That's a really good question. I bet you Mike can talk about that in operations. I would say part of it. Oh, repeat the question. The question is, hey, you've added all this additional context to the SBOM. At what point are you adding too much and it just becomes noise? That's a great question. I think, at least from my perspective, and then I'll let Mike jump in. I think you don't really know how your user is going to use your SBOM, and so more data is better. And so I think, like, I talk a little bit about the license use case and the deep scanning necessity that I have. So this information is really useful there. But Mike, maybe you can give someone a different perspective here.
So I think it's highly dependent on what is the purpose of what are you trying to communicate to whoever's consuming that SBOM? So for example, if you're just trying to communicate like software composition, including, for example, let's say up-to-date vulnerability metadata is maybe not the most important thing, because again, that's just going to be a snapshot in time. But, and Ian's brought this up a few times, is communicating, for example, if you're trying to communicate to your customer, these are the vulnerabilities we know about right now that are in the product. Hey, it makes sense to actually communicate that as part of the SBOM. So if you're using it for, so it really sort of depends on the purpose that you're trying to use it for. But generally, I think it's, if the information is useful, obviously it'd be nice to include it. But it depends again on, it's usually some sort of communication between the producer and the consumer of that SBOM on what they're trying to get out of it. And we'll learn more, I think, in the operations section about like how you can sort of do some of that without necessarily getting everything into the SBOM, especially if some of that data is going to be temporal, like vulnerabilities.
Plus, I think the other fact is that the more information you have in the SBOM, it's always possible to take like a fully loaded SBOM and distill it to a simpler document that is more fit to the use case than, because the other way around, it's impossible to go back. If you have like SBOM missing data, you cannot document it unless you go to a process like this.
Let's see if this works. Great question.
Hey, thank you. My goodness, I'll just put it farther away. My question is about relationships. Now, SPDX at least has a great potential to track what I consider parent-child relationships between software packages. And one of the biggest problems we face is knowing about those relationships or being able to detect those relationships between multiple components in your SBOM. Are there any tools on the open source market that you know of right now that could add potential relationships? Like not knowingly, but perhaps even just like the potential of a relationship between two software packages.
So there's, we'll learn later about a tool called GUAC that is in the OpenSSF that does some of this. But in addition, from Google, there's an open source API called deps.dev, deps.dev. It's a website that it itself has a bunch of information about the relationships inside of different open source packages. And again, some of that is going to be speculative because until you've actually built the software, you don't always know, did it pull in version 1.2 or 1.3 and stuff like that. But deps.dev is also a really good place. And later we'll learn a little bit how GUAC uses deps.dev to figure some of that out.
Thank you.
All right. So now we have this I'll say higher quality, maybe more complete. Man, no one jumped on that. No one wanted to jump on like the quality debate. So now what do? We're gonna look at verification, and I'm gonna turn it over to Porco to talk about that.
All right, so verification. What does it mean to verify the end result? So there's verifying the results is at times it can be super subjective, but we can do some analysis. I mean, the first one is there's the formal verification if it meets the spec or whatever, but I think it's more important to go into the semantic details added by the enrichment and augmentation process. So this is using another tool from Interlink called SBOM QS that attempts to has opinions on what is good quality. So you run an SBOM through it, and it gives you some quality measures. So this is the results on the augmented SBOM. So here's a comparison between the SBOM before the enrichment and augmentation process and after the augmentation. So as you can see, for example, in the NTIA minimum elements category, it went from having 0 components with a supplier defined to a bunch of them, like a really nice improvement. So from 0 and then to going all the way to 4,000, 2,000 of the 4,000 components having a defined supplier, which is a substantial adding of information. The SBOM authors, we added who is generating the SBOM, so now it's passing that check. As Ian mentioned, a bunch of the components now have licensing information that improves the score. And it's also detecting deprecated licenses in the code. All right, so going back to that discussion about the relationships in the components. So first, it's important to see if the structure of the SBOM more or less looks sane before. This is kind of the verifications to do, like we can do manually before letting the SBOM into the wild. So if we go back here to our exercise environment, so we have this this small tool. It's coming to the Protobom project. So the idea is, for those of you who are not familiar, Protobom is and we call it like an I/O layer for SBOM data. It is a neutral representation of SBOM data. So we ingest any format and it can write any format. And this library is part of a new project that's coming to the Protobom universe, intended to be able to make dependencies from a bunch of whole different data sources to make the dependency data visible to Protobom. Right now, it can ingest the documents by themselves, but we also want to make the project aware of dependency data from other sources. And as part of that, we're building also a visualization and graphing library, which can render simple. One of the drivers that it has, it can render in the terminal the dependency data. So we can ingest the enriched SBOM, and then it shows us the graph that turned out. Like, this is only important to understand where everything. So you see the Go mod package at the top, the kubectl module, and then from there all of the language dependencies. I mean, that's simple, like a simple example of how to see the data inside of the SBOM. So the other one is in the OpenSSF, we had like a probably too long a conversation on how to name SBOMs, because everybody's pushing out SBOMs in the GitHub releases. So we're trying to come up with, well, what's the best way of, can we just agree on a name so that all the open source projects more or less publish using the same schema. So we came up with this naming recommendation. It's in a document in the SBOM Everywhere group in the OpenSSF. So probably we should return to and rename our SBOM to follow the standard. So I'm gonna copy this one. It's Control V, okay. Okay, so we now have an SBOM named in that way. Okay, So now signing the SBOM. So we're gonna go into two ways of adding. Sorry, question.
How did the SBOM meet the minimum elements?
How did?
Yeah, when you were showing it on the screen, you said you had enriched it, you ran a tool on it. Looking at that, it's much better, but doesn't meet all of the minimum elements.
Yeah, no, so not all of them have a 10 score. So if you see the components with supplier, we're still missing some of them, which would mean that it's not there yet completely.
A lot of the components you may find are like intermediary components. So, you're generating an SBOM. What I found is sometimes they're intermediary components that are part of your build, and they don't trace back to an open source package. And so in that case, it's kind of on you you are the author of those components, those intermediary components. And so there are, I'll say, there format specific tooling that does a really good job with that. But because we're trying to be format agnostic here, we're kind of left those out of the slides. But yeah,
Okay.
a lot of the times what I have found is yes, there's always going to be some information that's missing. And then especially if you look at stuff like, I think there's some great scoring in here that you can see didn't do very well, like this multiple vulnerability lookup ID, I think is a really good one. I don't see a lot of tools that do both CPE, Perl, as part of like their typical generated SBOMs. And so I think those are areas for the tools to improve. I'm dancing a little bit around what you're saying, which is like, hey, is this meeting the NTIA minimum elements? And to be honest, I'd say for most part, it's best effort today. I've yet to see a lot of SBOMs that truly meet the NTIA minimum elements. I think in the spirit of like what's intended, because you can do a lot of like no assertions all over the place. People will be like, yeah, you meet the minimum elements. Like, well, no, you didn't. You didn't meet the intent.
Okay, so moving on to signing. So we're gonna see two ways of signing the documents. One is a simple detached signature where you distribute your document along with a certificate and the signature so that you can verify it. These examples all use Sigstore, which is a project of the OpenSSF to make signing easier. We won't go into that, but well, we'll show the example. So it's a little bit tricky to run it in the Gitbot environment. Oh, okay. So, well, we have an intermediate step here. So we need to, once we did the verification and before distributing the SBOM, something else that is useful is creating so we've been working with a cyclone DX SBOM. So to have maximum compatibility with our recipients, it's always a good practice to also generate the same SBOM on the other standard. To do that, I'm using the same tool I showed earlier to visualize, except so this is just a tiny wrapper around in front of the libraries for SBOM for dependency ingestion into Protobom. And what this does, like it's not a translator, but it only reads an SBOM and writes it out in another format. So instead of just printing out the terminal output like that, it's just going to spit it out in SPDX. So if I were to show you the resulting output, it should probably be equivalent to the other one that we just showed. So you'll see that the same information is contained in here. Okay, so let's go back to signing. So to sign, we're going to use cosign, which is the command line client for Sigstore. So this is going to do when I run this, it's going to grab the SBOM file as a blob, generate the signatures, and that I think about it. Let's see if we have an account to go through the flow here. So Sigstore uses, okay, copy. Let's see if this works. Okay, we have our test GitHub account here. Okay, I think it's gonna work. So Sigstore uses an identity provider to generate that temporary certificate for you so that you can sign the documents and then so this is if you were doing this on your desktop, it would come like it would pop up your browser, you just click on it and it's done. But since this is not detecting the browser here in the Gitpod environment, it's using the device flow where it gives you a URL and you come back with the code manually. So it's there. So now we can see that we have the certificate here and the signature. And we'll do the same for the SPDX variant. So we have it here. So this is using the temporary GitHub account that we created for the subject to identify itself and then generate the certificates. Okay, so we now have the CycloneDX version, the SPDX version, and both with their signatures and certificates. So to verify, okay, so we'll go into verification a little bit later, in more depth. So I'm going to skip that section. Now, the other way of signing, let me go back to the slides. So the other way of signing is generating an attestation with the SBOM in them. There are a lot of projects in the supply chain sphere, especially in the OpenSSF, where we think that the best way of generating a visible and more transparent supply chain is by generating metadata as your software builds and gets tested and gets distributed. And all of that information should be captured on forgeable documents, which we call attestations, and of which the SBOM is only one kind of. So for example, you can have attestations detailing how the software was built, which we call provenance attestations. You can have attestations relating what kind of testing tools you apply to your software as it was built. You can capture the results of vulnerability scans in an attestation. And the idea is that at each step of the build process and the software development lifecycle, you start generating more and more information so that you can make more informed decisions regarding how secure the software you're getting from the previous link in the supply chain is, and also detect the missing pieces. So you can answer questions as, for example, what kind of testing did you perform? Well, look at the station. What build system was used to build this piece of software that I'm getting? Who were the people involved in adding all of the commits to the code base? All of that can be captured in standard attestations. And the same is true for the SBOM. So if you want to have an SBOM that was generated, for example, at the same moment that the build was. So the same build system and same source code was used to build the system and also generate the SBOM. That can be captured in an attestation, so it's very valuable to have it there. There are many tools that can be done, but I'm going to do it with another pre-release tool that we're building to make this super easy. So the important thing with the attestation is that you have what we call the predicate, which in this case is the SBOM, and it's always tied to a subject, which is something, most of the times, a hashable object, which is a file. So in our case, we're going to be attesting to the kubectl tarball that Ian downloaded in the first step. So let me go and copy the example code here. So this is a small tool called Bind, which is also going to probably make it into one of the OpenSSF projects at some point. It just makes it easy to work with attestations and has all of the Sigstore signing built in. So I'm going to go and do the same here. So this is going to go through the same flow, generate the assigned attestation. And we'll do the same for the should have brought a mouse. Okay. Okay, there it is. Okay, same. Authenticate with GitHub. Get this. Oh,
Did you re-sign the SBOM that was signed by Sigstore, or did you sign an SBOM that hadn't been digitally signed yet when you did the attestation?
so in the case of on the first example, just signing with the attached signatures, we have the SBOM here, and then we have the signatures. This is a certificate and the signature. So in that case, you have the original SBOM untouched, and then the other two files. So if you distribute them, you need to grab those three and put them in your GitHub releases. And in the case of the attestation, we now have an attestation here. And inside of that is everything contained in a redistributable bundle. So we're going to explore what's inside of that file in a little bit.
Awesome. And can you talk just a little bit more about Bang? Was it like BANG, the name of the small tool that's looking for a home?
Yeah, it's a small tool under development that is trying to tie all of this together. So probably my thinking is we're gonna donate it to something. I don't know. But right now it's just like using all of those technologies into one to make it easy. It's just like a CLI to make this like seamless.
Thank you.
Yeah, we're gonna see a little bit more of that. Then, all right, so going back to the slide. So now we have, as we mentioned, we have the SBOM, the plain SBOM, the signature and certificates, and we also have two other variants of the same SBOMs. So this is the CycloneDX attested SBOM wrapped in all of the verification material with the Sigstore signatures in that. So when you have a bundle like this, you have at the very, very, very core of it, you have the SBOM, and then that one is wrapped in an attestation. So I have a slide that more or less. So here it is. So you have at the very core, the blue part is the predicate, which is the SBOM, like the untouched, unmodified SBOM. Then that one is wrapped in the attestation, and it's paired together with a subject, which binds it to the artifact that we are attesting to. And then around it, it has more JSON, which contains all of the verification material needed to do the actual signature. So it has the signature, it has the certificates, it has the timestamp inclusion proof that Sigstore adds, so that you can verify that when you signed the SBOM, the certificate was valid. And all of that gets packed into a single distributable file that you can use to verify, which we're going to do in a little bit. So what do you do with those two variants of the SBOM? Well, the common practice that we've been suggesting is that you take those two files that already are packing a lot, and then you basically transform them into a single line JSON and put them all in a JSON-L file, linear JSON, which is one JSON document per line. And then that way you can pack all of your attestations. So in this case, 2 attestations each for one SBOM, but then in the same file, you could distribute all of the provenance information, all of the vulnerability reports attested, everything in the single file. And so with the same tool, we can do the same. I just put here, and then this will produce a single bundle. So this one. So this JSON-L bundle is a file that has 2 lines in it, with each line being the bundle of the SPDX version of the SBOM and the bundle of the CycloneDX version of the SBOM, signed and verifiable in the same one. All right. So until now, we have our distributable artifacts. We have the plain SBOMs. We have signatures and certificates for those SBOMs. We have individual attestations, and also the bundle that packs everything into a single file that you can distribute. So once you distribute it, the recipient needs to make sense of what they're getting. So we have a question. Yeah.
So is there any logging capabilities that kind of happen on the back end just to make sure that wherever copyrights or licenses are getting grabbed is kind of tracked? Because I know you said you got to take note of that, and there's risk, associated with bad copyrights or maybe forged licenses, bad redirects, stuff like that.
So there is a project in OpenSSF called SBOMit that's trying to tackle some of that. So the idea of SBOMit is, how do you take the same principles of attestations, but instead of unwrapping the entire SBOM, you wrap portions, maybe an individual component, and you detail how did that component get discovered? How did specific metadata about that get added? And so I would say in general, no, to your point, not today, but there's a need to be able to compare different SBOMs. Like, one of the big things that people always throw shade at on SBOM is like, hey, I ran Trivia and I ran SIFT and I got completely different counts for components. Why is that? One of them has to be wrong, right? And well, the reality is that's not necessarily the case, right? SIFT may include your GitHub workflow files, the other one didn't. But the intent of SBOMit is to be able to pull out those differences and show the origin of that information, how it got into that SBOM. So SBOMit is a project that's trying to tackle the question that you have, which is, how do I know how and why this information was added into an SBOM?
Now, when it comes to those comparisons, is there any significant differences in the way it's presented if maybe one source is not comprehensive versus 2 sources being, just completely different? They both can't exist at the same time.
I mean, I think that's kind of one of the challenges with just sort of the SBOM tooling right now is they're getting better. But again, I think a lot of times it's unclear what the intent is of what am I trying to communicate with you? Am I trying to communicate, hey, here's all the first level dependencies, or am I trying to communicate, I included as much as humanly possible. I might not have gotten all of it, but I'm trying to at least get most of it. I think that's one of the challenges. And I think one of the things that we've been pushing in the open source community for SBOM tools to do a bit more of is actually say, like with SBOM and some of the other tools, is like, tell me what you're actually describing so that if I go back, can I determine, no, you missed something versus you got something wrong? Because right now, I think it's actually very difficult to determine I got something wrong versus I just missed something.
Okay, thank you.
Right. So sharing. I got all of these distributable artifacts. What do I do with them? So where do I put them? How do I see what's in them as a consumer that's, especially as a consumer that's receiving them? So the landscape is maturing, and then different areas and project types and open source versus commercial are in at different stages. So taking this scroll, walk, run approach, right now, so for example, you can, if you're releasing software, especially open source in GitHub, there's nothing preventing you from putting those documents in the GitHub releases. Then commercial folks who are building products to be able to push the documents and host them and make them available are also like already out there. And then something that we are very, very excited about is the ecosystems themselves also starting to host the SBOMs in their projects. Like, for example, PyPy is currently in the works to have all of that dependency information as part of the packages. You can also push SBOMs into OCI, which we're going to see an example in a little bit. And there's, of course, the commercial SBOM exchanges. So like Manifest and GitHub also has this attestations feature. So the attestations I just showed, you can push them. If you build the attestations that I showed you, you can push them into the GitHub attestation store. It has a few requirements, but it can be done today. And in the future, we expect to see the maturing of supply chain specific exchanges of this information, such as SCID and the Transparency Exchange API going on in at ECMA. So a few do's and don'ts of distributing and exchanging SBOMs. Please don't email them. The documents are supposed to be read by machines, so put them in some place that machines can get them, and the same goes for when you have an NDA in place. It's, I mean, it's transparency, so sometimes NDAs make exchanging of transparency difficult. Same for signing terms of service before getting to see the information. Then what would be encouraged? Well, whenever you have a distributed live artifact, distribute the SBOM with it, and then ensure that everything can be accessed by standard protocols and access. Sometimes you need to be a customer or whatever, it's fine. But once you have those credentials, don't put on like an excessive burden so that, so if a customer already has a relationship with you, make sure that the credentials they have are enough to for them to access the documents. All right, so, and then as a customer, you need to verify the artifacts that you're getting. So how do you verify them? So in the case of the detached signatures, we're gonna look into how to verify the SBOM that we did. So the verification that we're going to do here. So first let me show you what I'm gonna do. So this is going to use cosign, the same tool from Sigstr, to verify the signatures in the certificate that we just produced. So I'm gonna put the command here. Okay, so I run it and cosign return. Okay, verification. Okay, now there are a few caveats in this, and you'll see this in the example pasted there. If you see here, I'm cheating a little bit because I'm passing an anything regular expression to both the identity provider and the identity itself. So inside of the certificate, if you get the certificate and analyze it with OpenSSL, then you'll see that Sigstr embeds in the certificate the identity of the person who signed the SBOM. Now, when you verifying is not enough. If you only verify the signatures, the only thing that you're getting is that the file was not altered. But the good thing about Sigstore is that it embeds the identity of the signer, so you can know that not only wasn't the file wasn't verified, wasn't modified, but was actually signed by the person you're expecting it to. But you need to specify that. So if you do this, you're not really taking advantage of that. The reason I put this here is because we needed copy-paste instructions for the workshop. So you would, in this case, I would need to specify GitHub and the identity of the account that we use to verify. But well, I mean, you get the idea. So you can toy around with the commands in the repo to verify it. And then the other is, well, verifying the attestation. So verifying the attestation goes through the same, it's more or less the same process as verifying the signatures. So if we just verify the attestation by itself and we don't do the identity check, then it's going to say, okay, it verifies because of the contents of the file check out. But then it doesn't really give you a lot. So when you verify as a consumer, you need to know who should be signing that and ensure that the identity matches. And you can also in more or less try to see inside of the attestation to understand what you have in there. So you'll see that, okay, so what's inside the attestation? Okay, a Cyclone DX, and it's wrapped in a Sigstore bundle. Okay, nice. And then finally, can you how can you get back your SBOM from the bundle? Well, you need to unwrap a whole lot of JSON, which you can do by using JQ and base64 and other tricks. But this if you use the same tool, extract statement, it'll give it out the individual layers if you want. So you can see here that inside of it is the SBOM that we generated, and it's and you can see here the subject and the hashes of the tarball that we used as a subject to verify. And yeah, so next up, retrieving and storing them.
Thanks, Marco. So I think, you know, we got a lot of information about how to verify these. How do we make sure the integrity of them is complete? Next, let's talk a little bit about how we want to retrieve these from places and push them someplace else, right? We're talking a lot about redistribution, right? So the common question I get is, that's great. You need an SBOM. How do I actually get it, right? So that's what bomctl within the OpenSSF is trying to solve. It does kind of two things really well. It allows you to fetch SBOMs in a tree structure, so it will recursively follow along internal references in an SBOM, and then it will allow you to push that entire tree someplace else. So again, thinking about the idea of, like, say my employer, say an F-35, what does an SBOM for the F-35 look like? It's going to be a ton of individual suppliers providing their individual SBOMs. I need a way to collect those, and I need a way to build some representation of a system, and then I need to be able to push that SBOM someplace else. So I'm just going to jump in, for the sake of time, directly into the environment here. And so what we're going to do is we're going to fetch from a URL. And you'll notice here, I'm just passing along a single URL. And it goes out and it actually ends up fetching two different SBOMs, one in Cyclone DX and one in SPDX. Mind blown, right? Maybe not. But the idea here, right, is like, how do you represent a Helm chart? You may have an SBOM that represents the top level Helm chart, and you may need to reference an SBOM, say, in Docker Hub for an official image. How do you show connectivity between these different locations with these different SBOMs? That's what bomctl is trying to do. So we can go ahead and just like list the bombs in the local representation here. It'll tell us that we have these two bombs. I can do fun things like export this and run, say, into ripe. So I'm going to do bombs export. And it represents it in Cyclone DX. I can do the same thing and just tell it DSF SPDX. And using protobomb as the foundational library underneath this, will then spit out the same bomb in the different format. So I was able to grab a CycloneDX SBOM. It happened to download internally referenced other bombs based on a single component, output in a different format. You can now, I could do the same thing for the other SBOM. And I could do the same thing, converting that SPDX one to CycloneDX. So, hey, we've downloaded some bombs. We have them in our internal representation. Now I want to push them someplace. So in this example, we actually have little OCI registry running. And it automatically is pushed like the hello bomctl 0.0.0 version. Let's go ahead and we've grabbed these SBOMs from a URL. Let's turn around and push them to the OCI registry. And you can do this in this little environment. So we got to get the URL and whatnot, but you can then turn around and push that bomb to that OCI registry. And if we take a look, it will now have, should have updated. Says that I pushed it. That's not what I wanted. Well, it should have pushed it. It says that it pushed it. I'm going to say that it did push it. But that, again, that movement, right? So we took bombs from one place, we put them someplace else. Today, it focuses more on GitHub, GitLab, URLs, OCI, and we want to expand this tooling into things like, say, commercial offerings like Manifest or dependency track. So again, I have a whole bunch of bombs. I need to get into dependency track. How do I actually move a whole bunch of SBOMs into dependency track? How do I move them into, say, a commercial registry? How do I give them to my customer where they're not going and clicking individual SBOMs from a website? That's what bomctl is trying to solve. And with that, I'm going to skip ahead into operations to give Mike the last 25 minutes.
All right. So now that we learned how you can generate SBOMs, enrich them, do all sorts of stuff with them, and then share them, associate identities with who generated those SBOMs or injected information in those SBOMs. What do I do with them? And I know that, one of the challenges we've had for a while is right now, SBOMs are mostly being used for compliance. And that's one of the reasons why I think folks like Ian get an SBOM that has information like Acme, app or whatever in there, or like insert, commercial name here, is because folks are just sort of throwing them in a bucket somewhere. They're throwing them in a share. They're emailing them and just expecting nobody to actually be doing anything with them. But, hey, they actually do have a lot of great uses. And let's kind of go through what some of those things, what you could actually be doing with them, especially with regards to vulnerabilities. So let's first talk about sort of operational maturity. So don't, for as much as I like tools like, for example, GUAC, which we'll learn about a little bit, or even tools like dependency track, if you just have a handful of SBOMs, you don't need to go and spin up a bunch of different commercial tools and do a whole bunch of stuff for that. You can use some of the tools out there, like, if you're just trying to pull down those SBOMs, you can use curl for a lot of that. You can use bomctl and so on. You don't necessarily need to use the GUAC sort of ingestion system. And then you can also, individually scan various SBOMs for what's the current state of vulnerabilities using tools like Gripe, Trivia, or OSV Scanner. If you have a few more SBOMs, right, and you're trying to compare between them, you could start to use in-memory tools. Once again, another open source tool up there, DuckDB. It's all in memory. I can load in 100 SBOMs and start playing around with them. And then sure, if you have a lot of SBOMs, look at tools like GUAC, look at tools like dependency track and other sort of, look at vendor tools, for example. And then what are the outcomes we want to get out of these SBOMs that we're sort of using, right? Well, one of the things, right, is if I have more than one SBOM, right? If I just have one SBOM, I can look at what are the vulnerabilities, maybe things like license risks, but hey, for us, it's all about vulnerabilities. We can determine what changed between two versions of the same software. It could be vendor software, it could be open source software, it could be software we created ourselves. And so what changed between those two versions? Did we, if I scan vulnerabilities in one version and I scan vulnerabilities in the other version, what got fixed? Or maybe what didn't get fixed? What did I inadvertently introduce? And then also over time, right, vulnerabilities are reported and discovered. Hey, I ran a scan against the SBOM yesterday. No vulnerabilities. Today, vulnerability was discovered. It was disclosed. It's out there. And now I can run that scan a second time and be able to see, oh no, a vulnerability was introduced. And then that helps you also understand, hey, organizational risks. So am I using 12 different versions of the same log4j, right? And that actually all of them are vulnerable or half of them are vulnerable. What impact does a risk actually have? And then, again, what risks? Things like vulnerabilities, licenses, and then also just version and dependency sprawl. So we won't have enough time today to like really go into GUAC because again, also GUAC will not run in Gitpod quite easily because it's a whole database and everything else. But if folks want to just, here's the documentation on GUAC, and you can kind of use that to kind of follow along at your leisure. There's a Helm chart and a Docker Compose file for that sort of stuff. All right. So as we kind of mentioned, as it was mentioned earlier, there's really no current standard for exchanging SBOMs. There is the Transparency Exchange API that is being worked on as right now, but there's a lot of different places. And some of those include things like being sent via email, which please don't do that. It's maybe only marginally better than the other one, which is told over the phone, which is actually a approved version, approved way of exchanging SBOMs. But common ways are, GitHub releases, OCI, some package managers like NPM will support it as well. And so, hey, just use curl. Like you can just download it. You can just download the SBOMs. Again, this is for open source. If you have vendors, they'll give you usually an API or they'll send it through some other mechanism. The same, so next up, so once you collected those SBOMs, you then want to optionally, I would say, ingest them depending on, again, how many SBOMs you have. If you have, again, just a handful of SBOMs, you could just collect them locally in a bucket and then run scans against the SBOMs that are there. But if you do have a lot of SBOMs, you can go in and actually ingest a lot of those into something like a database, like a GUAC, like a dependency track, or another solution. And so what's great about tools like GUAC is you can actually track changes over time. So you're not just looking at an SBOM as a snapshot, right? You're looking at, hey, yesterday I had version 1, 2 weeks later I introduced a version 2, I generated 2 different SBOMs, I can compare between them and so on. And so, for example, with GUAC, you can kind of, you can ingest all of that in. And then once you've sort of either ingested or otherwise collected SBOMs, you want to be able to correlate them with additional data. So similar to a sort of SBOM enrichment, but it is different, is as opposed to sort of saying, hey, at the moment that I am like looking at this SBOM, here's all this data that I'm able to pull in. You can look at a database like a dependency track, like a GUAC, to actually pull tons of additional metadata about the supply chain. For stuff like vulnerability management, right? So, hey, if I'm ingesting lots of different SBOMs, I can also go in and correlate it with additional sort of vulnerability information. So in this case, for folks who are not super familiar, there's an open source project that comes from Google called OSV Scanner, which is part of, it utilizes the OSV database for folks who are familiar with that. It's essentially just a database that aggregates like GitHub service advisories, various other package manager service advisories, pulls them all in to and pulls them all into sort of one database that uses this sort of OSV schema, which is a nice sort of JSON schema for vulnerabilities. And you can go in and run like a scan against an SBOM and essentially enrich the data. You can enrich sort of the information that you're getting from SBOMs. And again, this is super useful if you are integrating it with other sort of runtime analysis tools and all those sorts of things. So for example, in the previous example with GUAC, you can do that with a couple of different flags when you're actually ingesting the SBOMs. Like you can do add vuln on ingest, which itself will actually call out to OSV. To do that, it also has the add EOL on ingest flag, which will look at end of life.date, as well as a couple of other things that we're exploring in the open source. And then also add license on ingest is, it will both look at and potentially correct licenses. So there's an OSI project, which is the open source initiative. There's an OSI project called Clearly Defined, which has a bunch of lawyers actually actively looking at various different open source projects and traversing their dependencies to better understand, hey, this thing claims to be MIT licensed, but hey, it relies on something that's AGPL. That's a problem. That's actually not the right license. And so there's some stuff there as well. Then, hey, once you've sort of correlated some of this data, what can you begin to start doing here with it? So you can use something like DuckDB, again, if you have a handful of SBOMs, again, not a ton, but if you have a handful of SBOMs, you can use something like DuckDB to create in-memory tables of those SBOMs. And it's very simple to sort of do that, where, in this particular case, for those who are not super familiar, DuckDB you could just sort of give it JSON and it'll let you just sort of run SQL against that JSON. And it can auto detect and sort of generate in-memory tables out of that. And then here we're just sort of selecting what are the distinct packages against all these sort of SBOMs in that Git pod. And you can kind of get just a list of the unique packages, for example. So, hey, without duplicates, what are the unique packages across all SBOMs? And then so then, like for example, with GUAC, you could also do things like, right, since I'm ingesting all this data, I've collected all these SBOMs, I've ingested them into GUAC, I then correlated all this information with EOL information, with vulnerability information, and so on. I can then actually ask questions of my supply chain about what do I know right this second about all the software in my team, in my department, perhaps across my entire organization, right? I can ask questions like, give it a Perl, right? A package URL, guac1 query vuln Perl, right? Which will just list me all known vulnerabilities that were ingested. And again, GUAC is something that will over time continually what they call like certify, where we'll just go out and once every hour or so pull all known pull all known vulnerabilities against all the packages we have and constantly update based on that. And, we can also do stuff about, hey, what do we just know about this package? What does this licenses have, and information like that. And this helps answer questions like, did I actually fix the vulnerability, right? I updated some stuff and I updated a bunch of things and, released a new version. Did that actually fix the vulnerability? And then probably more importantly, for a lot of us who are often dealing with vulnerabilities at like scale, is this something that impacts one tool that's in dev, or is this something that impacts maybe my entire organization? Which is, of course, can be pretty scary. Like, is it the next log4j, or is this something that, hey, yeah, we should get to it when we get to it. It's only in dev. We haven't released it. So one of the other things you can do, right, is once you kind of have some of this information, you can actually begin to run actions on this, right? You can go and use tools like OSV scanner. You can use tools like NPM. If you're like an NPM project, you can do NPM audit fix against stuff. Now that you have all this information about the vulnerabilities and everything else, you know what to sort of prioritize regarding fixing, which again, not everything is just as easy as, if you're on GitHub using Dependabot, right? Sometimes you're like, I need to prioritize because again, these things could have impacts to features, to a lot of other things. And so you want to be able to, now that you've sort of analyzed that data, you want to say, okay, what do I do about these vulnerabilities and so on. Now, one of the things that GUAC can do, right, is GUAC, you can actually do like a patch plan, right? Because we have inside of GUAC, essentially, we have all this great information about the SBOMs. We're correlating it with things like the information from OSV, deps.dev, et cetera. And then as you pull in more SBOMs, we can potentially even build out a bigger picture of your supply chain. So if it turns out you have, as an example, I have an SBOM for a container, and that container contains Acme app. And then Acme app, we have an SBOM for Acme app, which itself has all of its dependencies. We can combine both of those in GUAC to then build out a bigger sort of essentially connect those two graphs or connect those two trees. And that makes it very easy for us to then create like a patch plan of, hey, in order for me to fix an issue in the Acme app image, I need to first actually fix the Acme app binary first. And then once that's been fixed, I can then kind of do stuff up the chain, which is always, I think, one of the challenges with what we have a lot of times is, hey, I have a vulnerability. It's somewhere deeply nested in a transitive dependency. It's hard to sort of figure out. If you have SBOMs that are relatively complete, relatively accurate, you can begin to sort of answer the question of, okay, is this something I just need to fix? Like, do I just need to update my my package.json for, and then, do an NPM update? Or is this something that, hey, I need to actually go in, update this binary, and then update another binary, and then update the base image, and so on? GUAC will help sort of answer some of those questions as well. So some future work inside of some of this that you can start to look at, right, is, hey, now that you're actioning on some of this, right? Right now, a lot of the actions I was talking about would be manual, right? You are going out there and running these commands yourself. But in the future, right, what you're able to do is, and we have this, set up in a couple of different demos, and, the QR code there is for one of them. As you can look at policy as code, right? You could start to look at OPA, for example, and say, hey, if I start to see vulnerabilities show up in a couple of the areas that, if vulnerabilities are showing up or if something is seen as being suspicious, I can actually block it from running in production. I can go in and say, hey, this policy triggered, which then triggers some automation, which will automatically, let's say, remediate that issue. And again, that's up there's a demo of that up on YouTube for anybody who's interested there. And then also runtime correlation. So now, hey, I have a bunch of information about the vulnerabilities and my supply chain and all the source code and binaries I have, but then what's running and what's running where. So for folks who are familiar with Kubernetes, there's a tool called Kubescape, which is underneath the CNCF. It's another open source project that looks at what's running inside of your Kubernetes clusters and can, block issues, help remediate them. But one of the things that you could do with Kubescape in addition to GUAC is you can actually go and say, hey, this is what we know about the software just generally in our supply chain. And then using runtime analysis, you can actually, and eBPF, you can see whether or not the vulnerable packages are even loaded into memory. And hey, if they're not loaded into memory, maybe, you should still probably fix it, but maybe it's not the most immediate thing to fix. That one, the talk, again, the talk was recorded, but KubeCon was just last week in Europe. So that is going to take a little while to upload, usually within another week or so. Okay, did you want to talk?
Yeah, well.
Oh, sure.
Hi, John Kavanaugh. So we've been working on the commercial side, but I really want to applaud all your work on the open source side, because I think this is a broader view. And the pace that you're working at is, on a contribution type of basis. What we're seeing now is an increase in vulnerabilities and also an increase in complexity. So I think, yeah, you keep going on the open source side. But I've done some research, and one of the things is, are we getting any of the ecosystems, the GitHubs, the GitLabs, all of those to be at a common definition and operating standard?
So the answer is the work is being done. I saw him walk past a few times, but Michael Windsor's here from Alpha Omega, which is an OpenSSF that they call the directed fund. Essentially, they're very much focused on sort of helping fund some of that. So the challenge here is there's a couple issues. One is NPM. They're a little bit easier. They're owned by GitHub, which is owned by Microsoft. PyPI, completely nonprofit, right? So for them to kind of reach there, we need that money to be able to sort of help them along. So when it comes to that sort of stuff, I think there's a lot of work there being done to do that. And in fact, there is a bunch of initiatives within OpenSSF to do that. The challenge, again, is going to be making sure that the funds are there so that they can hit that, because hey, we're all in open source, right? The amount of times I've heard from, again, I'm also in commercial, so I just, but the amount of times I've heard somebody reach out to a maintainer and say, you need to fix this. No, I don't. You don't pay me, so I don't need to fix anything. And I think we're seeing that also in regulations as well, where we're seeing there's pushes to make folks like the LF, the Linux Foundation, OpenSSF, and other sort of nonprofits do a bit more, right? But as far as the sort of general, like, John Smith, who's, sitting in a basement on the weekends, he likes to hack on a library. It turns out that library is being used by multinational corporation in their product. And hey, something just got exposed in it. That's multinational company's problem, not anybody else's. But with that said, there's definitely interest among, nobody wants to be unsafe generally. But I think more people want to be able to say, hey, if we can incentivize the John Smith to sort of fix his thing, or say, hey, maybe as a multinational corporation, I shouldn't be using a single maintainer project. He has a lot of awesome stuff in there, so he doesn't want my help. Great. What we're going to do is we're going to fork his project and we're going to put it underneath a foundation, right? So I think we're starting to see more of that. There's a lot more work to be done there, but folks who are interested in the OpenSSF, we're kind of fostering a lot of that.
Second question. So all of this is related to software componentry. We've been focused probably for 3 years now on how do we deploy it. So the hardware, the IAC, infrastructure as code. So do you know of a standard that's encapsulating those elements that would then be joined to the SBOM to give us a complete vulnerability picture?
So you're talking about like, so let's just use an example, like, hey, I have some Terraform,
VPC,
Yeah,
storage, cryptology, all of that stuff.
Yeah, so I think that's, a little bit less mature right now. I think what we're starting to see is folks throwing some of that in the software bill of materials in some capacity. So like something like, hey, here's the VPC configuration file, and we add that as something that's in there. I think the challenge is, software, it's a little bit more, I would say, if I give you a binary, largely it should run the same on one system as another. Whereas if I give you infrastructure as code, a lot of the stuff there, it kind of gets complicated as this is, theoretical VPC until I actually run it, and when it becomes real VPC.
Right.
So there's some challenge there.
Yeah. So what we've done is we've made a visualization of all that. So we're not using GUAC. We have a knowledge graph, but the developer's laptop's different than the SIT environment, which is different than the QA, which is different than the prod. So it's been our work to see that we need that unique environment of each deployment and capture all that in the same way you're doing with componentry. So we'll happy to talk more about it.
Yeah, yeah, definitely. And that's kind of actually one of the reasons, again, with like Kubescape is doing runtime correlation. And so I do think that there are tools that are sort of beginning to emerge, or integrations with tools that are beginning to emerge to essentially ensure that, hey, I'm running it and here's all the places I'm running it. And I think the next levels are going to be things like looking at attack graphs and all those things, and then looking at how it sort of aligns with the, the data that's coming from the supply chain from an SBOM, so that like, hey, actually there's a vulnerability here, and because you're accessible on the network here, here, and here, this is where somebody could get in.
Yeah, so after the end for the closing remarks. So if you are not tired of seeing attestations and you want to see them in action and how we're using attested VEX in the Kubernetes project to issue the project's VEX feeds, I'm going to do a talk in like an hour from now. Do you want to close it?
Go ahead.
And yeah, so that takes us to the end of the workshop. There are some useful links. Everything that we just went through is in tutorial form in that GitHub repo that we shared in the beginning. So that should get you, if you want to go over this again, if you're not bored. So yeah, you can try out all the tools, and here we go.
Yep.
All right. So thank you very much. And we'll be around during the conference if you want to have questions, go through any of this again. Thanks.